everyone. I hope you all are doing great, and we welcome you to another session on DevOps and Kubernetes. Today we have Tarun Marwa sir, who is a lead DevOps at ABB and a multi-page personality. He has taken many sessions on DevOps with us, and I hope today also he is going to deliver a nice session with huge knowledge. So I hope you all will be doing great. And let's start the session on Azure, Kubernetes, and how to secure it. Over to you, sir.
Yeah, hello, hello. Good afternoon, all. So this is So I think thanks for hosting me today, Varun. So to get started, yes. So my topic is like basically how to secure the DevOps pipeline to deploy the AKS cluster. So Kubernetes, once from I will let you know how to get started on the Kubernetes from the administration perspective, like what are the daily routine things which we need to taken care when if this session would be, I hope this session would be helpful to the folks who are going to take Kubernetes administration certification. So yeah, and then probably this is the session for like deploying the applications to the Kubernetes infrastructure without the overhead of the virtual machines. So Kubernetes, as you know, it's a orchestrating platform which is which was developed by Google almost, I think, almost in 2014, almost it's completing almost 8 years back when the Kubernetes term were initially introduced by Google company. And yes, if you are starting in Kubernetes, I would suggest to go through the basics, and this is the site you can probably refer to. Yes, so this is a site is probably you can refer to once when you're starting your Kubernetes journey, because security administration come on the advanced topics. So Kubernetes as an organization as a is maintained by cloud CNCF organization, which is Cloud Native Foundation. So there is a organization which is who is maintaining the Kubernetes, and who are it's an open source community. But this is product is developed by Google. But yes, if you are getting started, there is one more step, like associate certification which Kubernetes have introduced just a few months back. So once you're getting started with Kubernetes, it's very important you to know. Although I have pinged the URL, so you can go through all these topics like create a Kubernetes cluster, deploy an app. This is like as low as you can start with your own desktop lightweight Kubernetes also. If you don't want to have a Azure Kubernetes things, so this is the K3s is the thing, like lightweight Kubernetes. So to get your journey started, as because is Azure Kubernetes or a Google Kubernetes or a EKS, which is the Amazon Kubernetes cluster. It's an advanced one, but for this one, you can get started. Great for Edge IoT CI. This is like the certified Kubernetes administration distribution build for IoT and edge computing. So this is lightweight Kubernetes, which is you can just go through the K3s version of the Kubernetes, and it will give you the some information on the Kubernetes, right? So it is great for the edge IoT CI development, embedding Kubernetes in situation where a PhD in Kubernetes clusters is infeasible. So what is K3s? So it's a lightweight, is a single binary lightweight storage. If you don't want to have a overhead of starting with this one, the heavy infrastructure, you can play with this K3s. So this is basically the this is just want to give you the insight of the lightweight of Kubernetes, which you can refer through to when you are starting your Kubernetes journey, to so that you can configure this as low as on your machine itself. So it will help you understand, and it gives the information how it works. It's a lightweight one. I think you can get started from here itself. If you face any doubts, you can let me know. But yes, this is lightweight. If you are starting the Kubernetes journey, then this is the basics ones. Obviously, this is the Bible of the main the link for the Kubernetes to start your journey. Uh, and Kubernetes basic modules like create a Kubernetes cluster, deploy an app, expose your app, and then expose your app publicly. So probably this we will see here, although because it's Kubernetes provisioning is taking time, that's why what I have done is I have created the infrastructure for Kubernetes. So this step is skipped, and then we need to start from the deploying the application through a. We will go through the deploying the application through a say Azure DevOps CI/CD, and then with a already containerized ASP.NET Core application, which we need to deploy using the Azure DevOps into the Kubernetes cluster, which the into the infrastructure which we have already provisioned. So only first step I have done in order to save some time and in order to cover more. Then the third thing comes is like we will check our app. We will see how it's behaving after it been published, and then we will expose our app publicly. We'll see we can access the app publicly. Yes, so that's what we will do, and then scaling up and updating application I will try to cover, but I will show you the features. But I think this I'll try to cover fifth and sixth, but of course till fourth is the scope of this one. This particular session, like deploying the application, exporting the application, and expose the application publicly, and what are the basically the logging and the monitoring tools which Kubernetes used internally to monitor the cluster health. So health checks. So how it will do. So those things we will explore, right? So also I would like to share the slides. It's not much of them, but yes, the resources which I've been following is these ones. I can quickly show. Yeah, it's been yeah. So skip. Yeah. So let it open and then probably I can walk you through. So this is the DevOps Labs, the pre-configured lab which I'm following up as already having a ASP.NET containerized based application, which is this is the lab scenario. Like we will build. This is a lab contains a Dockerized ASP.NET Core web application, which whose name is My Health Clinic, and it is deployed to a Kubernetes cluster running on Azure Kubernetes using Azure DevOps. So there are two, and then other important thing is there is a YAML file, MHC AKS YAML manifest file, which consists of the definitions to spun up the deployments and stuff, which is like load balancer will act in front and the Redis cache in the back end. So this is how the overall infrastructure of the thing will look like. So first, the local Git repo will commit the code in the Azure pipelines in the container registry, and then yeah. So and then it will push like let me see if I can pause and show. Yeah, I think yeah, it's been done. So here by yeah. So if you see here, this is from the CI phase. So like from DevOps to Git repo, there is a Git repo which I've cloned, whose name is I will go through the name Kubernetes, I think, and then it's a CI pipeline which will push the. We will first build the image. We will first build the image and push it into the container registry, and then this container registry, if you see, yeah. So once it goes through, so then it comes the Docker image. Docker image you will push to the private container registry as a public container registry as well as a private container registry as well. So once through CI we will make it as public, but it's a private container registry where we will push the Docker image, and through pipeline again the backend is the Redis cache, front end is a load balancer, and there is a database for the application which we are going to host. So yeah, so once it comes I can show again. So CI, this was done. Now in CD part, we will deploy this application to the SQL will be the backend. The front end pod would be the this one, and the backend pod is the this one. So front end pod is kind of the load balancer, and the backend pod is the Redis cache, and then we have Azure SQL to maintain the Azure SQL database to maintain the database. So now walking you through the infrastructure, this is pretty much entire infrastructure which have been provisioned comprising of public IP, container registry, network security group, route tables, virtual machine skill set, virtual network, uh, and we will go through the advanced also, like what are the type of virtual network. So this is a CNI model which we are following. There are two type of networking services for Azure. For Azure, like not only Azure, for general Kubernetes, one is CNI and one is the CNI and one is the KubeNet. So we are following the CNI where the we will create Kubernetes at the virtual network at the same time when we are creating Kubernetes service. Rather than on deploying on the existing VNet, we will provision the VNet along with the Kubernetes when we are deploying the actual infrastructure. Then we will go to manage entity of the. We have to create two managed entities. One managed entity for the Kubernetes itself, and one managed entity for the like. We will create two managed entities, one for the Kubernetes cluster and one for the one could be acting as a OMS agent to monitor the logs through the container instance. So that will actually monitor your the cluster health actually. So the name of which is the container insights, which where we will monitor the health, and then this is called a solution. Then we have a storage account to store all the details, log analytics again for the monitoring the cluster health of the cluster, the health of the clusters and Kubernetes, load balancers. We could use see there are the different here also there are different categories. We could either use the ingress controller or we could use the load balancer. So there is a difference like which one to choose from. You can just refer to a couple of sites like which one to choose, load balancer or ingress controller, load balancer or ingress. So you can setting up the load balancer with ingress. So this is for the in Azure in AKS. So load balancer versus probably the couple of videos already there. So load balancer only works at layer 4. Service unaware of the actual application can't make any routing consideration. Ingress controller work at the layer 7, which can have more intelligent routes to distribute application traffic. So I think we when we are saying we have route tables also, yes, then we are using the internally we are also using the ingress controllers to route the route table is to for the application layer. So we are using both the load balancer as well as the route table. So then we have SQL database, network watcher, managed entity, again for the OMS and then the SQL server. So these are a couple of infrastructure which is going to deploy. Make sure once you do the hands-on lab, you delete the resources, otherwise it will cost you very heavily. So that's how you should make the practice. Like after every hands-on lab you perform, you delete the resources. This is this is the subscription which I've deployed is my own pay-as-you-go subscription, where actually I am paying for all the resources which I have been. I'm the account admin, so I'm able to do pretty much all the stuff which I need to do. So these are the resources, and I have deployed all things in one resource group, which is I think AKS Hands-on Lab 0409. Pretty much all the components I have deployed here. But then, if you provision this thing right, if you provision this what you say the hands-on AKS lab, right? So it will create one more resource group. In this resource group, you will have the container registry, the cluster, the databases, and the SQL server. But in the this one, you will have the let me go. This MC cluster is there, which will actually host you the what you say the public IP, the node, the agent pools, the node pool, which is the virtual machine skill set, which will host the nodes, the nodes of the AKS cluster, and then the managed entity, virtual network, and Kubernetes load balancer. So when you go to this AKS hands-on lab, we will go to like the type of the cluster which I have deployed. Then let's see how many nodes cluster is it. The version is 1.223.3, and I think it's a one node pool. So it means a one node cluster which we have deployed. One node cluster we have deployed there, and this is the So in the Kubernetes, when you talk, you have what you have in Kubernetes. So you have clusters, a two node cluster or single node clusters. So we'll just walk you through a couple of the examples. So Kubernetes, uh, like Kubernetes best practice in Azure. Best practice for cluster security. Of course, we have like these the documents baseline architecture, cluster operator, and developer best practice to build and manage application on Azure Kubernetes services. So this is the one, but I think there is one more thing which I want to show baseline architecture. For AKS, baseline architecture for AKS. So baseline, this is the when you're deploying, when you're architecting your AKS cluster, you need to set up a baseline. Like so, as your Microsoft recommends a hub spoke architecture to provision your infrastructure. So this is the one more thing which I want to just emphasize upon. Like this is you can follow and probably let me also while I'm also learning me also do these things like capture all these things. So when then like Kubernetes for my reference as well. So and then we have the lightweight of Kubernetes, which just we were covered. So yes, so this is a baseline architecture for an Azure Kubernetes service. So an implementation of this architecture is also available in the Git repo. So this is my next target. I'm trying to do all these things with my own. So with my own repository, this is the repository which you can use to and this is like the other one which I'm showing, but this is the baseline architecture. Like once you start your journey, this is like for the beginners. This I won't be able to cover the all the basic stuff, but this is one or two level above the basics one. So you need to equip you yourself with the tools and tools which you can configure. So this is for the designing the architecture for the Azure Kubernetes, a baseline architecture, and this is the entire view, uh, the topology and the architecture, also planning the IP address range, deploy ingress resources. You can utilize this. So when you say a Kubernetes cluster, if you see this diagram, so this is a single node pool. This is not a multi-node. This is one node pool. So what will happen? This is forms one cluster. Cluster is a big thing. It's a one node cluster. In cluster comes the different nodes, right? This is one node. This is one node cluster, and in node comes the what you say the pods, different pods. It can be two and three pods. In our case, it would be two pods, and under two pods, in the pods we have the images like Redis cache and the load balancer. So the front end is the load balancer and the back end is a Redis cache. So those are the containers inside the pods. So these are the pods. So cluster is a big thing. Then comes the node pools. Then we have under node pools we have what you say the pods, and in the pods we have the containers, and containers are communicating with each other with a bridge network. So that's what this is these IPs are. So the wherever you see Docker images, Docker bridge means the containers would be interacting the multi-container. This is a multi-container application. Front end where front end is the load balancer and back end is the Redis cache. So for them to communicate with each other, we need a Docker bridge, CADR. So this is that component. The Docker bridge, the container range IP address. This is the private range IP address automatically allocated by Azure, since we are provisioning according to the Azure standards. And this is the pod CIDR. Like this is the container CIDR, and this is the pod CIDR. Like it's a huge range, like 16. And then we will have a node CIDR as well, node pools as well. We will have. So this is the CIDR for pod, and then this is the API networking address. And for monitoring, we have key matrices which are being monitored, node pool, all these things, service and ingress namespaces, which we can create default namespaces as well. We have as of now we have four default namespaces. We have like these are the workloads, core DNS, matrices, OMS agent, services ingress. Just want to make you sure that you understand all these things like Kubernetes health share, health model, matrices server. So this is a replica set created, and we have a storage for the persistent volume of each. So because each container will have, so it's a it's a it will host operating system. So pod, I think the pod is the smallest entity in the cluster. So then we have a containers inside it. Then we have this configuration. So we have a node pool. I hope you are able to connect on this one, right? So DNS, this Docker bridge is the container CIDR, and this is the pod CIDR. And if you go to the node pool is the what you say. Let me go to node pool one. So this is yeah, the count. This is because auto scaling is enabled as of now. This is like a three node which is configured right now. We'll go to node pool. That the maximum size is three, like where the cores is like two CPUs allocated to each node actually. So and then this is the although this is not being used those that much is it's not been used, but yes, this is a Linux based operating system which we are running, and I think it's a Ubuntu image. I will walk you through the repository which I have the YAML, and then you will come to know all these things. So maximum pods per node, there can maximum pods is 1110 pods can be there accommodated inside that node. So and OS disk sizes, this is a system configuration. And when you go to the nodes, like the nodes architecture, so these are three nodes which are running with this image, and the node image version is Ubuntu 18.04, and this is the container runtime version. When we have configuration for these nodes, right? We have the update image. We can upgrade the Kubernetes, and then all these things are there. Like you can update the image scale node pool, and all these things you can just go through all these things. So once you have provision, so and then you have different three nodes cluster. This is a three node cluster, and which with each node can accommodate up to, we saw that configurations, right? Which each node can accommodate to how many pods, like maximum pods per node. So one node can contain maximum 110 pods, and inside pod we have containers. So this is the maximum limit. This is a huge limit set actually. So and then we have the configurations for this node pool. So this was important thing. That's why I have shown. And then we have these DBs will come once you walk through, and then we have container registry. So this is like before I come to this, I think it's good to walk you through the steps which I have taken to reach until this step. So like through the CLI, right, through Cloud Shell, there we need to first create a, what you say, this is what I have created. This is the storage account to launch the your shell, the Azure CLI, which has been hosted when you go to all resources. Here is the storage account created. This is the storage account created for the purpose, and we have containers inside it. Sorry, overview, and then we have so this is the storage account created for the what you say for managing the work which we are doing. So this is the file share which has been created where I'm doing my own stuff, the performing the commands and all those things, Cloud Console. So this is the file which has been used 5 GB. I can store the data. So file share, and this is that file share which I'm using actually. So to provision the infrastructure. So then these are the version, like this will list you the basically the version available. So what you can do is I have uh, so let me just paste this thing for you. So this is to get the region. You specify the latest version available in Azure 1.2 3.3. So this and then you keep on creating this resource group. This is for creating the this is once you have created the resource group, this is for creating the AKS cluster itself with the available version with this value stored in the dollar version. You can specify a variable value here. So this is the variable, this is the value which you will get, will store in a variable name as version, which is 1.223.3, and this will generate an SSH key to log into the node pools. So to log into the node pools, you will use a SSH key because it's a Ubuntu-based machine. So this is the command B which will use to provision the AKS environment, and then you will create the what you say the ACR, the container registry. While remember when we walked through the architecture to deploy the Kubernetes, right? The architecture which we're going through. A container registry is a very required step because we are in Kubernetes is a container orchestration engine. So it needs to have those containerized images which it will pull from the this is what you say the container registry, right? So this is the step to create container registry with queue as standard location east us2. So once let me walk you through. So let me go through as I show. I will go to the resources which I have provisioned. So this is the one. So this is the registry which I have provisioned, and this is like yeah. So I think this is the one. Yeah, this is the one. So location SKU size is standard. You have SKUs available. Like standard is the one which you have created, and then we will access through all the repository will be stored here. The containerized image. Once we build the CI/CD pipeline, you will see here images getting updated. So this is what you is a container registry, and this is one thing. And then we have, now we are updating the, so see, for container this thing ACR, for ACR to contact with the cluster, to read the to so ACR to contact with the cluster, it needs to have some permissions, right? So this is the command to attach that permission, where the permission name is ACR poll, right? But we will again verify with this article which we are having, right? But I think it is most probably is ACR poll. Yeah, it's a ACR pull rule because this will a container the Kubernetes will pull the images, latest images from the container registry. So that's what it will do. So for this to happen, you need to go to the probably the container registry and go to the activity this role assignment, and when you have the role assignments with you, this is the managed entity. This is the managed entity of the AKS cluster which we have assigned. This is the name is ACR pool, right? So this is we will this attach to the container registry, right? And this will what you say this will attach to the container registry, and this is the ACR pool role which you are given. This is the managed entity. We remember when I was going through the basically all the things. This is the managed entity which we have provision. I think this is the managed entity. This is the managed entity. This one always I'm talking about. So there are three ways, right? Service principal, managed entity, through which you can basically, these are the terms which can help you to connect with the Azure Active Directory, for you to connect with the Active Directory. So these are the components to communicate, to have a communication mechanism established. So this is the ACR pull role which you have given to this managed entity. So yeah, so this is the role assignment which we have done. So this is like ACR pull role which we have given, right? And then we this is done. Then of course after this step, you yes, this is the thing which I need to show you. So see, these are the couple of container registry rules and permissions. We have given ACR pull rule, right? For the ACR to the Kubernetes means it can pull the images. So this is the very important table, guys. Once you start on the basically setting up the permissions for the ACR, these are the couple of things which which container registry can do. Like if it's an owner, he can perform all these things. Contributor can do all the things except the signing of the image. Reader have a limited, he can access resource manager and pull the images. Where ACR push will do the push and pull image, and ACR pull will pull the image. ACR delete will delete the image, and then where the ACR image signer will sign the image. So this is the important table for your role permissions. So this is what it will do. It will assign the ACR pull permission for the container registry to the AKS. Now we have the database also, right? So this is the SQL server, and this is the database which we have created inside it. So I can just quickly show what are the things we have. So this is the SQL server which we have created as a backend, because we are hosting a website, right? Health-based application website. So that's why we need a SQL server as well. And this is the SQL server, and we have created a firewall rule also. So which will, as of now, see there is an option to deny the public access, network access in the SQL server. So here I have added my personal IP address, which is so that I don't face any issue, and allowed the Azure services to interact. Otherwise, we won't be able to interact SQL Server with other services of Azure. So, and then we have inside the SQL Server, we have the Azure databases as well, which whose names is MSCB So this is we have configured a S0 SKU pricing tier for the DB, SQL Server DB, and this is what we have. And yes, so this is the pretty much the infrastructure which I think which I've tried to provision. Any doubts still here? Because after that we will configure the pipelines, the secure pipelines to provision the infrastructure to deploy the application on the infrastructure. As of now, there is no application running on the infrastructure. So any doubts still here? We have. I think it's pretty much clear, right? Or yeah, I think yeah, it's pretty much clear. So, but I will just like to take a pause. Yeah, I think this is we can go with the DevOps, right? Now to provision thing. Yes, so we can start. So see, as I was referring to, this is the basically the lab which deploying the multi-container application to Azure Kubernetes services. So now we will what we will do, once we have configured the infrastructure, we will configure the pipelines. To do that, this is see this is what I have told actually. So this is this will provision you once you go to the open a new tab, it will provision the repository, create this project for you. Once I sign in, I will show you so that you don't face any doubt while you try to configure this. So yeah, and let it come. So see, template is already chosen a template. You can choose the template, and this is for I think for the Kubernetes you have to choose. This is the template. So this template provision a Scrum-based team project with the code work items for a sample ASP.NET Core web application My Health Clinic. This template is also includes the pipeline definition to build a pipeline definition. It also creates a pipeline definition to build and deploy the web application to Azure app service, right? So now this has been done. So let me go. So this is the repository which I wanted to show, AKS1, right? And this is the multi-container app. This is the the what you say. Let me go to this one. So multi-container app is an organization. Under this we have what you say, the AKS project, right? Generated by the this Devops tool generator. Now when you go to repository, this is the main file which I was showing. This is one is a Docker Compose. Docker Compose will publish this image. myhealth.web is a Dockerized file. We will have this. This is the main file we have, and then we have this is the main file for the deploying application to the manifest file. This contains the service and deployment definition along with the labels and all those things, right? And this is the DACPack file to deploy the SQL deployment. This won't be visible here. And there is the NuGet packages. Of course, you will be able to see the content. So, but yes, this is the important file. So this is like you can this is like the API version apps and the deployment file. This is deployment manifest file. This is called deployment manifest file, where you define the backend, which is the MHC back and speculations of this file, which have when we have one replica set and match label is MHC back template speculations. Then we have containers. This is the MHC backend container, which is the Redis, and the Redis is running on 6379 port. And then we have a service also getting deployed. Service is MHC back again, plus is the cluster IP of the service. Redis 67 is the port, and this is the MHC back. And then we have deployment as well, which is the front end. Front end is the what you say the MSC front is the application, the front end application which will be deployed, and the strategy is the rolling update one strategy. So if you want to know more about rolling update, what it is, the deployment strategy, rolling update in Kubernetes. So this will give you some performing a rolling update. This is like performing a rolling update. What is a rolling update? Objective performing a rolling update using kubectl, updating an application. So users expect applications to be available all the time, and the developers are expected to deploy new version of them several times a day, right? In Kubernetes, this is done by rolling updates. So once if you want to do updates, it can be done with the rolling updates. If you want to deploy a new version of application without being the user knowing that it's a disruption to the service. So this is the feature in Kubernetes, which is called a rolling update. So rolling updates allow dependents update to key place with zero downtime by incrementally updating pods instance with the new ones. Right? It's incrementally updating the pods with the new ones. The new pods will be scheduled on nodes with the available resource. So this is like the rolling up the concept of the rolling updates. Would suggest to just read about it. Yeah, so that even I will document this thing in my this thing. Sorry. Yeah. So this is the concept on the rolling updates. What the updates will this will as it's clearly mentioned, it's a like platform for a like when you want to update your application multiple times a day without user being the node. So that concept is called rolling updates inside Kubernetes. So that is what it is, the rolling update. So max search is one, and maximum unavailable is the maximum search which we can give. This you can read about this. These parameters will be mentioned there. So then we have selectors like front end, which is the application of the front end. We have labels, metadata about the template, containers. Yeah, front end is the application. Image is this is the image. This image will be deployed to the what you say the container. Will see those image getting deployed in the once you go to the this one, right, container registry, right? So this image will be deployed here actually, like in the repository. Here it will be deployed once we build this thing. So this name will with this name with the latest as the newest version of the image will be deployed. So that is MST front end application, which is getting deployed. And image policy pull always. This is the image pull policy. Containers is it's running in container port is 80 for this image to be run. And this is the resource quota. So sorry, not this entire. So this is the resource quota. This is the resource quota which we have to give. CPU for this container image would be 250, 250. It can go to 250 m, and CPU limits is 500 m. So CPU limit, yes, you can just read about it. What does it means? Meaning, it just means what CPU resources are defined in milli cores. If your container needs two full cores to run, then we put the value 2000 m. If your container needs on one fourth of a core, you put 250 m. So your container only needs one fourth of a core. That's where the value is. One fourth of the core machine is needed. The CPU consumption of that container image. And this is the maximum thing, like yeah, this is the half of a core, which is very small. And then this radius is the backend, right? And this is for this radius image, environment is radius for this one. Whereas yeah, so and then we have the service, which is getting corresponding service, which is getting deployed at front end, which is the load balancer service. Service is load balancer running on port 80. Okay, and the backend is a Redis cache with name, and this is the resource quota for it. You can just read about this resource quota. And this is also a very important, like resource quota, resource resource quota Kubernetes. So resource quota, you just read about it. This is the like how you allocate when several users or teams share a cluster with a fixed number of nodes. There is a concern that one team could use resource quota tool for administration to address this concern. Like there is a concern that one team should not use more than its fair share of resources. So this is you read about the resource quota where we give all these parameters. Like all these parameters are given in that. So we give pod, CPU, memory, right, which we are giving now. So this is the resource quota. So this is the another important component. So just to yeah, so this is the resource quota. So this is like the resource quota for this one. So this is nothing but the resource quota, and this is the backend. And then we have the version, like the service, the actual service, which is the front end service, which is the load balancer running on port 80. And this is the label for that. Selector is MHC front. Then we have the NuGet packages, right? And then the README file is the PowerShell command to perform some updates. Yeah, so this is also to check the things basically to if any things are not going right. So yeah, so this is a couple of YAM family files I want to just go through, and then this is the Docker based files which you will also see in the structure. So this is now you're trying to configure the build definition. This is already configured now. This is the definition already created. Now we need to edit these things, right? We need to edit these things. So MSC k8s build, I think should be fine. Name should be fine. Azure pipelines, of course, we need to select not 16.04. We need to select. Let me see. So which is the agent pool which is selected? So yeah, 18.04 we will use. Probably this is the step for replacing tokens in app settings.json. This is also very important file. Somehow I app settings.json is also one of the important file, which is with this will contain the connection string of the this is in the source directory, right? Source directory myhealth.web. This is in the source directory myhealth.web app settings. Yeah, this will contain the connection strings, the password which we have specified. So I think I will update. Yeah, I will update. Should update, but I think if not, then I can need to give these things. Like let me try to update these things. But it will trigger. Let me. I will give the passwords. No issues. So this will contain the connection strings, which we have MHCVDB and all those things. It will pass in the value. This will contain the connection string. So this is app setting foundation where we don't need to configure anything, right? This is already there. and this is replace token MHC, AKS, MIML. So this is to replace the tokens here. And then we will configure here the run service container registry. We'll select the what you say, the available services. ACRC, it will all automatically came because there was already service connection established. Else, if not, then you need to this kind of error will come and you need to authorize this one. You need to authorize this application. Then only you will prompt it to authorize. Then if you prompt this, a connection endpoint will be created. In my case, I have created this endpoint already, so it doesn't. It's detecting my ACR registry, uh, which is this thing. I think this is the registry. So this automatically detected my registry, and this is it was taking the build YAML file from my repository, and the action is run service image. These says there are so many what you say the actions which build, push, run, log, write, run. So this is the run service image we need to do. But here we need to do only this configuration, which is container registry and the Azure subscription. In each step, we need to do these things. So let us do this thing. It will come here, and once it loads, yeah, and here also. This is the CI part which we are doing right now. Like it will the first part of it, like the pushing of the image, the CI part which I was showing in the diagram earlier, and this is the YAML file which we just saw actually in the repository, right? And then we have the log services, container registry. You will see. This is the YAML file which is we have trying to run build push is the build is trying to build this one with the like action like build service image, run build and then push. This push is the command, and then k8s will pull this will push the image, and the command it what it will try to do is it will push the service image. This is the log service image. While doing all these things, it will log the image so that you can't update this current one, the existing one. So it will log that service image. So these four steps are very important: running, building, and pushing and log. So like this is like same as you do in the normal. If you have a Dockerized image in the local system, you will do couple of manual commands to do these things. So this will be done using these steps, and then we have this copy files. We will save, and then once we have this. See, it was mentioning the application file contains the connection strings. This manifest file contains the configuration of deployment service and pod, which will be deployed in the case. The manifest will look like as below. This I think we already even gone through. We just looked into it, and now we will go to click on the variables. We will configure the variables to store like the ACR name, SQL, password, username, and user. These things we need to capture. I think, yeah. So ACR name, I think again, which is the this is the ACR name which we need to give, right? Password again, when we are giving the password, we will hide this one. For our sake, we will see just once, yeah. Then we will lock it. Okay? SQL Server. So this SQL Server is the uh, this is the SQL Server, right? We'll update server name. This is fine. We can expose it also. SQL user, yes, of course. If you want to hide it, you can hide it. SQL admin. Or if you don't want to hide, it's okay also. Now, when this is done, we will go to save the changes and we'll configure the build pipeline option. So we'll edit it. So we will just save this one. Like configuring the build pipelines, this is optional basically. Like we also have a build pipeline that if that's something you are interested in, like to proceed you through the YAML pipeline, choose My Health AKS Build YAML and click Edit. If you utilize the YAML pipeline, make sure to update release definition artifact link. So like this is optional step like configuring the build pipeline through YAML, but you can do this thing using these steps, right? You can configure this one, but I think it's not required. Either you do with which we have done already, or you do with this thing, build service, push service, log service. You can yeah, but yeah, I can show you through like you can go to the choose AKS build YAML and click edit. So when you also have YAML build pipeline, if you're interested to proceed with the YAML pipelines, choose YAML and click edit. So in the repository, you have to choose this file. This is through the pipeline as a code. If you want to do with the pipeline as a code, then this is the thing you have to do. MHC AKS AKS build sorry, if you go to the pipeline. This one you can go to the I think this is like navigate to the pipelines and then pipeline and then I think this is I have not configured. This is the older version, which but yes, this is for the YAML based. If you want to do this, can be done using a YAML based also. Same step which we've already configured. Variables also we can mention, but then this is the exercise tool which we have to follow now. From here, since build definition is ready, now we need to go to the release definition. We need to edit it. Of course, we need to edit it and configure, right? So this is like backpack, and we have to select our Azure subscription. SQL authentication type is this again the same thing, which is the same. And SQL, this is Windows authentication, SQL authentication. All these things are available here, but we are using SQL authentication here. So it will we don't have to mention anything username and password. It will take from the variable which we configured in the CI pipeline. It will take from there. So backpack file, it will publish this publish extract. This schema will be published. A backpack file which is already there will go to this step quickly, creating the deployment service in AKS. So this is the creating the from the deployment manifest file. So deployment service and pod manifest file. So this is through that, and like the service connection type is not as Kubernetes, it's a Azure resource manager, which we are having, and this is the pay as you go, which is subscription, and this is the one which this is the Kubernetes cluster. Again, the all things will come automatically. If not, then there is a issue with your service connection. Namespace, see namespace we saw, right? Namespace, if you want to mention any custom name, like see Kubernetes is having a namespace. Let me show quickly. If you go to the this thing, right? So about namespaces, you can go to this thing. What is a namespace? This is the cluster. When you go namespace, is a logic identity to define a create with a YAML or create a starter application. It's a naming convention. Your team, different teams will be working on a different projects, right? They can mention their namespace. Namespace the logical entity to store the things. It's a see you namespace. It's a work kind of workspace. In your if you say in a what you say in a workspace you have in the Databricks, right? Similarly, in AKS you have Kubernetes, you have namespaces. So you can quickly know about the namespaces, what it is, namespaces in Kubernetes. So this is uh, not this one. So yeah, this one. So see, namespaces is what in Kubernetes namespaces provides a mechanism for isolating groups of resources within a single cluster. So names of a resource need to be unique within a namespace, but not across namespace. So its deployment services. For example, you could be deploying Varun, could be deploying different namespaces. I could be deploying different services in my namespace. So each namespace has a quota also as well. You can create a custom namespace also. So this is a very important yeah namespace concept, which again you need to probably define this namespace concept. So this is what it is namespace. So which we are trying to deploy. So I just wanted to show what is a namespace. Here, I think we have not mentioning the namespace, but you can update actually. So here, the two steps is already it's been updating now. Now we'll go updating images in AKS. Then we will go to sorry updating images. It's in the pay-as-you-go model. Resource group is like we need to select his hands-on. Then the cluster name is. AKS cluster, of course, namespace. Again, there's a set command expose run get login to update the image. So this is the set command to set the image, update the image in AKS. So then I think update image in AKS task. So this is again this is a resource group. We have already mentioned right all these things. Cluster namespace is not required. Secrets. It's asking us to just go to the secrets to okay in secrets also we have to update these things. Secrets docker registry, container registry, Azure container registry, and subscription again we have to select ACR, and secret name is so this is create and deployment AKS. Create will create the deployment service in AKS for the configuration that is specified in the YAML file, and the second will pull up the appropriate images correspond to the build ID from the repository defined and deploys the Docker image to the front MHC front pod. It will deploy the image to the front pod running in AKS. A secret is created in AKS cluster through Azure Devops by using kubectl create secret background. This secret will be used for authorizing while pulling the web image from the container registry, right? So this is secret key for that. And then we have select the variable under that section. Now again we need to go to the variable like update ACR SQL Server for the pipeline variables. ACR is what? ACR is container registry. We need to update here. So we can, I think, expose this one. That's not an issue. And database name also we can specify. Um, the database name. SQL password is SQL user. I think it's okay to expose this user. Like you can, it's okay if you don't hide also. Okay, SQL Server name here. This is the SQL Server name which we have to put. It's okay. You can expose this username and server. Only the password thing you don't have to expose, because this should be locked. Always it should be locked. Remember that. This is a very important security aspect thing which we need to mention in the pipeline variables when config deploying the application using Azure DevOps. So then you basically save this definition, and then you go to the make build. This is for trigger and build and deploy the application. So in this exercise, let us trigger the build manually, and upon completion, automatic deployment of the application will be triggered. Once our application is designed to deploy in the pod with the load balancer in the front, dedication in the backend. So you need to go to the pipeline. You need to go to the pipeline and run the AKS build now. So in pipeline, right? We will see what challenges we will face. Uh, Previously, I had issues with using the agent. Let's see this time what happens. We are directly pulling from the master branch. Generally, it's not recommended to pull from the master branch. But the developers have different feature branches as well. That is deploying. That is part of the deployment strategy, the branching strategy which we'll use. Master is for the production builds. We'll pull the things from the master only if there is a production build to be application to be deployed. This is, I think, we have not defined anything in this variable. It's all in the pipeline variable which is defined, not in this one we need to do. So I think uh, variable continues. I think we can try. We'll see what challenges we will face. Just to monitor the logs. So I think I should run. I don't know how much time it will take, but probably will just this is the screen is important to check the logs, because after this a manual trigger. But basically, if you do any change, like in the pipeline, the build should automatically trigger. That is a service hook which you need to apply. This is the Azure repository, but you can apply service hook at Azure DevOps, Azure repos also. This was a Azure repository, the repo which we just this is the Azure repository. So yeah, it's running the services. Let's see how much time it takes. I don't know how much time it will take, but yeah. I hope we were good, right? Were in terms of the context, right? This is the Microsoft self-host Microsoft hosted agent. So this is the workspace. of that agent, home VSTS agent 2.0 Docker Compose. It's running AKS up build about on. This is the same command you run on the for running the Docker services. So this is running, just showing you this thing. Yeah. So I think it's still taking time. Probably I don't know how much time it will take, but let's wait till the time. I think yeah, this is the article to export the container roles, Azure Container Registry and roles permissions, CI/CD solution. Just go through all these informations we have, and once we deployment is completed, we should get some repositories in the ACR. Like here, we should get something if the build is successful. If not, then probably it will take more time. But I think and I hope the fundamentals are clear, right? How to deploy the service using DevOps, using a secure pipeline. I think it will take some time. Maybe it's taking time. I think it's already 5 minutes. Yeah. Till that time, yeah. So these are the couple of things. Till that time, let me show you the slides which I have. Yeah. So this was the agenda, and we pretty much looked into all these things. And this is like the container registry AKS SQL Server which we have provisioned, and it was a ASP.NET Core application which we have deployed using the container this tool, the demo generator tool, and then we have configured database deployment using CD in the Azure DevOps, initiating the build to automatically deploy the application. And then these are the couple of resources which we I have also extracted here actually. So first, just for your reference, 16 of them. Yeah. So let's see how it goes. Then we can probably see. But I think it's taking more than expected. But the build definition by default it's coming as YYY and this is dot one is the first run of the is the first run, right? So this is and the strategy of a DevOps pipeline should be like you should build only once, deploy multiple times. So I can retain this build and the next time in the project it will cost nothing to me, but obviously for the infrastructure it will cost. So you need to delete these resources after you have done with your labs, right? So this infrastructure thing components needs to be deleted to stop incurring the cost. Yeah. So that's the idea behind these builds. So I think it's taking slightly more time. I think more than I think it's already 7 minutes. It's running, but yes, I think we need to wait. Probably between 8 to 10 minutes, it should complete this task, run service. So I think it's already seven. I think couple of more minutes to go, and I think we should be done. Yeah, but if it's taking time, then probably yes, we need to wait. Yeah. once it's built, then it should publish this thing right in the repository, and then this switch back to the portal in the release tab, and then they should be done to once it launches the cloud shell, and you should get this thing pod should be running, and then front end, and then you copy the external application, and then you should be able to launch the application. But yes, I think it should be covered. Eight minutes. I think close to 9 minutes. I think it should be completed. It's- it's already almost 10 minutes. It's taking more time than expected, but yeah, creating network AKS default with the default driver. The repository webhooks. This is the webhook. You can add a webhook for ServiceNow or URL custom headers, push, pull, delete, chart, push, status. And I think this is okay. This is created default resource group for the container insights. It is created different resource group, and so two resource group it has created. One is the default resource group ES2 for containing the monitoring images like container insights and default workspace, and this is for the MC cluster where all the important things like node pool and route tables, VMSs, Kubernetes load balancer is there. I don't know why it's taking this much time. think I don't know why it's taking this much time. It's taking more than expected, I think. But it's- Probably, I think, Varun, you need to skip this part. Like 15 minutes has been running, right? So yeah, then once you
Sure, sir. We can skip this part. No issues.
because this is taking more than expected time than expected. I was expecting a maximum of 10 minutes, but it's taking, I think, close to almost 15 minutes, and I don't know what time it will complete this one.
No issues, sir. I have learned from you only. We have to be very patient while doing DevOps task.
Yeah. So yeah, let's see. I'm just waiting, but it doesn't take. Last time I deployed, I think it hardly took. I think 10 minutes, 10 to 12 maximum 12. But this time it's, I don't know what has happened.
No issues, sir. Please tell me when we'll wrap up
Yeah,
and
sure. Yeah, I think it'll take some time, but yeah, let us wait for a few more minutes and then uh, yeah, I think we have to wait. But yeah, let's see. In the interest of the time, probably we need to wind up. Yeah, but I don't know what this done process it's doing. Let's see. And let's see. Case deployment. This is the compare feature, very interesting till the time this complete. This is actually giving us the history, what it has been done doing actually. So pulled by different people whose names are coming now, and yeah, updated HTML, AKS YAML, and this is the changes which have been done. Like it was beta, now it's V1. Previously there were no labels, now there are labels. Then there are replica set. We have these named replica set, and so this you can do a side by side change. Side This is like side by side change which you can compare in the YAML file. So it's time 17 minutes. Blame. Yeah, so this is the SHA ID, SHA ID of the commit. When you do commit the code, right? And this is the SHA ID which is getting generated. In the meantime, probably we can look into. So -7 means, from -7 means plus 12 is the 12 changes in the right side. -7 are the ones which are added, which needs to be added, -7 places, and this is where plus 12 changes have been occurred, and this is -7. So this to compare the changes, you can see the details of the also the other, which I've tried to pull the image. First of I think I tried to pull it in back in I think 6 months back. So this is still in progress. I don't know what has happened. Let me close this. Half an hour, I don't think so. This step we used to take, but yes, let's see. But yes, I think after this, like what will happen is this image will be published. This will be published, and in the repository, we will see these kind of images till that time. And once we see the images, this will be again we will go. We'll see the images in the container registry, and then this will again come back to the release and see the progress. This all steps will process. Then after this, in the cloud shell you need to execute this one in the command to get the access of the credential of the Kubernetes cluster. So this even we can check now also this one. I think reconnect and we will do the checks now itself. Like as we are seeing some slowness, so we will this will create credentials locally and the in your AKS cluster and it will create a merged in context. So this will create my own file, so .cube, right? And this is dir, and you can do config ls minus la cd config. Okay, this is the file. This is it will store the file actually. So this is like done, right? So there here you will get the like cube kettle get nodes, cube kettle get nodes. It will display the nodes in the Kubernetes cluster. I think till the time this time which we can do, it's like it will show the pods. See, it will show the nodes, right? Three nodes. It has already starting interacting with your Kubernetes cluster. So get nodes, get pods. I think pods like we should see some. This is not running as of now. There is nothing being deployed. No resource found in the default namespace because this is still in progress. Once you see this, you will see these applications running, the front end and the back end. And to access the application, run the follow command if you see the external IP which is pending. But for some time the IP is assigned. So, but these commands will make sense once this is run. But this is how it is done. So I think, yeah. I don't know if there is an issue with. No one has mentioned this step. It's taking time or what. I think all have mentioned some other thing, but no one has mentioned that this is taking time. Uh, then I think I will leave to you, Varun. Or you want to take it because you might be also be running late. But yes, this is what I had to cover. I hope this is successful to show the pods. But yeah, sweet. I think there is a application in my PC with the step recorder. Probably I can record the step from here on. Like if you are getting late, yeah, yeah, just taking. It's not even erroring out, so I'm not sure what is the issue which is going on, so that I can quickly troubleshoot. It's almost 30 minutes. I use this image. because Ubuntu previous version also it was not allowing me 16.04, so that's why I chose 18.02. But also it's taking time. Going to end it. Taking 18.04. I have to troubleshoot as well because this is stuck in somewhere I even can't look into. It's yeah. So issue. I think it's yeah, it's I think it's getting some 40 minutes. So yeah, let's see if you want to give a cutoff time probably from your end. I don't know whether it will run or not. But yeah, I think let it run if you don't have anything for next half an hour. Varun, sir, should I, stop this build and try to repush it again and try this for next 5 minutes, or else I think
Sir, anything works for me. You can do as you like. If rebuilding, I think rebuilding is going to take another 1 hour.
yeah, maybe not sure. Probably I need to update the agent. Right now, the Ubuntu image is 18.04.
No issues, sir. We can schedule one more session if something.
Yeah, but the other case is like if I do a step recording from here, like if it's like if you want to join another session, so you can continue. I can send you the recording of the steps. What
Yes,
do you
sir.
say?
We can.
You can, right?
Yes, sir.
And then we can merge those steps, or how should we do? Because this is the tool I have,
Sir,
step
right now
recording.
I cannot say you the thing, but yeah, we can. I think we can podcast it in the two parts. Like part one, part two.
Yeah, I think we can do that.
That's going to be great.
Yeah, I think yeah, that's also going to be great. So sure, let me record these steps and probably can also carry on, and then so I think after 5 o'clock it's all, it's not a fruitful one. But yeah, up till 5 o'clock I try to cover.
No issues, sir. It was great. Let's wrap up with the session for now.
Yeah, let me record the steps from here. Then yeah, I can send you the steps recorded. Even because I don't have the estimate right now. I think yeah, I think you can end up the broadcast. Yes, let's see.
So thank you, sir, for coming here and delivering the session on Sunday evening as well and spending your time for community folks. So, folks,
No
stay
problem.
tuned with us for the part two, and then you'll be getting the detailed about the glitch we faced today. We are extremely sorry for that. And thank you, everyone. Thank you, sir, for coming here. See you. Good day.
Thank you.